array. The sequence or this line of similar elements are called array. So here you can see that we have a sequence or a collection of rings in a single line. So we call it a array. Okay. So in data structure, array is a linear data structure. When it is 1D, it is a linear data structure and it is store or it is used to store a collection of homogeneous element. Homogeneous element means what? All the elements are of same data type. Like you can see this collection of rings. So every element is a ring. Okay. The same way, if you look at this image, huh? So the collection of some numbers are given here. You can see 10, 20, 30, 40, 50. So it is a collection of five numbers. So these five numbers are of similar data type, and the data type of these numbers are integer, right? And another thing we need to remember when we are speaking about array is that all the elements are going to be stored in contiguous memory location in the memory of a computer. Okay, so we can imagine a memory map of a computer like a grid of memory spaces. Okay, now if we have five values in an array, it will be stored in contiguous memory location. That means back to back, one number here, to second number here, third number here, fourth number here, and fifth number is here. It is not going to store like one number here, second number is here, third number is here, fourth is here, and five is here. No, it is not possible. Okay, so this is what we need to understand, that all the elements are going to be stored in a sequence and in contiguous memory location back to back. Okay, now what are the characteristics we have already seen here? That it store elements of same data types. Memory allocations is contiguous here, and if another thing is here, that is index of array, which is very important throughout. Every time we will discuss about array, the index of array is very important. So here you can see the element position is called index, right? Index. So here 0, 1, 2, 3, and 4 are array indexes, right? So first element is at 0th index. Indexing is starting from 0, and you know uh, the number of elements minus 1 is going to be the last index. So here you can see we have total number of 1, 2, 3, 4, 5. 5 element. So last index is 5 minus 1 equal to 4. So 4 is the last element. Okay. So now later we will see that if we want to access particular element with 30, we can simply access this element 30 by this index number. So that is what is written here, accessed using single index. Size is fixed at the time of declaration. The size of the array will be fixed when we are going to declare the array. And see, if you see the declaration of the array, it is you know given like this: int a 5. It means what? It means that we have declared an array like this, and the array name is a. It is the name. Size of the array is going to be 5. That means it will store 5 elements like this image given here, and the indexing will be definitely start from 0 to 5 minus 1, that is 4 is the last element. Okay, and all the elements will be of integer data types. Okay, so this is one way of declaring array. Uh, then it support random access. That means, say if we want to access the third index element in the array, we don't need to go to the first, then second, then fourth, then third. No, we don't need to do this. We can simply access this element using its index, that is 3. We can write a 3. This will give us the access to the fourth element, which is 40. Okay, so a3 will give us access to 40. Okay. Now here is a small C code for declaration of an array, what I have already told you here, right? And initialization with these values, what we have used here. So this array of size 5, A is an array of size 5, which is initialized with 5 integer type numbers or elements 10, 20, 30, 40, and 50. Okay, so here you can see in short, A is the array name here, 5 is the size of the array, A0 is the first element, A4 is the last element. We will discuss more in the next video. Thank you.